Okay, we are working on using unit rates to convert measurements. We are doing pages 11 and 12 today. So number 1 and 2 I've already worked here. Number 1 says Susan has a 12-inch board for constructing a wooden chair. The directions say to use a board that is 29 centimeters long. Is her board long enough to cut? Okay, we're going to use the conversion, our unit rate here. They've given us 1 inch equals 2.54 centimeters. So that's the first thing you write down is your conversion rate. Then you're looking at the board that you have, which is 12 inches. So that goes on top to match the inches here. And then we're trying to find out how many centimeters that is. Now we're going to cross multiply. So we have x, just one x, equals 12 times 2.54, which is 30.48 centimeters. So since she has 30.48 centimeters, she has more than the 29 centimeters that she needs to construct the wooden chair. So she has more than enough. On number 2, it says Kevin uses 84 fluid ounces of water to make an all-purpose cleaner. The directions call for 4 fluid ounces of concentrated soap for every 3 cups of water. How many fluid ounces of soap should he use? And they've given us the unit rate. 1 cup equals 8 fluid ounces. So we write that down first. Then I have to take this in 2 parts. First, I want to figure out how many ounces is 3 cups of water. So I know what my measurements are for the water and for the soap. So 3 cups, we're going to match that with our 3 cups on top. And that is over X amount of ounces. That's what we're trying to find. So we cross multiply again. X equals 8 times 3, which is 24 ounces of water. So now that we have the 24 ounces of water, we're going to do a second conversion. We have 24 ounces of water, and that is equal to 4 ounces of soap. Because they tell us 4 ounces of soap is the 24 ounces of water. Okay, so that's what we're using to mix. Now, he's going to use 84 fluid ounces of water. So I'm going to write that on top so it matches this. Okay, and then we're trying to find out how much soap he needs if he's making 84 ounces instead of 24. So we cross multiply. 24 times x is just 24x. And that's going to be equal to 4 times 84, which is 336. Now I have to cancel out the number that is in front of the x, so I'm going to divide both sides by 24. So I divide that by 24, divide 336 by 24. So this just becomes x, and 336 divided by 24 is 14 ounces of soap that he needs. Okay, the next one, Shannon test drives a car in Germany and drives 95 kilometers per hour. What is her speed? What is her speed in miles per hour? And we have the conversion here. 1 kilometer is equal to 0.62 miles. Okay. So now we have our conversion. So she test drives a car in Germany that drives 95 kilometers per hour. What is her speed in miles per hour? Okay, so kilometers is going to go on top to match this, 95 kilometers. And we're going to put x because we're trying to find how many, whoa, sorry about that, that got blurry. We're trying to find out how many miles that is. So we're going to cross multiply. So we have x equals, and then we're going to take 0.62 times 95. So 0.62 times 95 is 58.9. So 58.9, and that's miles. Okay. The next one, Keith works 8 hours per day for 5 days a week. Okay. Melba, that's per week. Melba works 2,250 minutes each week. Who spends more time at work? Okay, well, I would rather have this all be in hours instead of minutes, so we need to come up with our own conversion here. First of all, they didn't tell us this time, but I think everybody knows that 1 hour equals 60 minutes. So that's the conversion I'm going to use. I'm going to put minutes on top. Okay. And then she works 2,250 minutes, so that needs to go on top to match this. And I'm trying to find out how many hours that is. So now I can cross multiply again, so I get 60x equals 2,250. Now I'm going to divide by 60. And I get 37.5 hours. Now this is for Melba. Keith is pretty easy to figure out because he's already working 8 hours per day for 5 days a week. So we just multiply that. 8 times 5 is 40 hours per week. So the one that's working more time or spending more time at work is Keith. It's his 40 hours. So Keith spends more time at work. Okay. All right. On to the next page, number 5. Jason runs 440 yards in 75 seconds. At this rate, how many minutes does it take him to run a mile? And they give us the conversion. 1 mile is 1,760 yards, so I'm going to write that first. Okay. Then I am trying to find how many minutes it takes him to run a mile. Oh, I've got yards, so I need to first do this, then I'll worry about this later, because I've got minutes, not seconds, and I have yards, not miles. So I'm going to put X for mile, and then 440 for the yards. And then I'm going to cross multiply again. So I have 1,760x equals 440 yards. Well, 440. It's not yards anymore. Now I'm going to divide by the 1760 so that this will cancel out. Divide by 1760 over here. And I get 440 divided by 1760, 0.25 of a mile. So it's 1/4 of a mile. Now we have to do the conversion for the seconds and minutes. Okay, so the second conversion would be that there are 60 seconds in 1 minute. Let's Just making sure I'm doing this right here. Minutes and miles. So 60 seconds. I'm going to do 1 minute is 60 seconds. Okay, so that's our second part here. Now, I know that he ran 75 seconds, so the seconds goes on bottom, and I'm trying to find the minute, that goes on top. So I cross multiply, I have 60x equals 75, divide by 60, and I get 75 divided by 60 is 1.25 minutes. Okay, so now for the last part, they wanted to know how many minutes it takes him to run 1 mile. Okay, so right now we don't know. We've got 1/4 of a mile and 1.25 minutes. So we need to find out the third part, which is how long it takes him, how many minutes it takes him to run a mile. So what we're going to do is minute per mile, and I'm out of space. Minutes per mile for the third part, for the answer. We're going to do 1.25 minutes over 0.25 miles. So that means I'm dividing that 1.25 divided by 0.25 is 5 minutes per mile. Because I got 5 here for this. It'd be 5 over 1. So 5 minutes per 1 mile. That was kind of a bear with all the problems in it. Okay, number 6. Another one like that. Okay, so we have boxes of granola are on sale at a price of 2 for $4.50. There are 12 ounces of granola in each box. What is the unit price in dollars per pound? Okay, first, I know that 16 ounces equals 1 pound. I'm going to need that conversion. So I want to start there. So I'm going to do 1 pound is 16 ounces. And okay, and there are 12 ounces in each box. So we're trying to find out how many pounds each box is. So we're going to cross multiply again. So 16x equals 12. So then we divide by 16 and we get x equals 12 divided by 16 is 0.75 pounds per box. Okay, we know there are 2 boxes because it says they are 2 for $4.50. So I'm going to take that times 2. So I have 1.5 pounds for $4.50. I hope that makes sense to everybody. 1 box is 0.75 pounds. I've got 2 boxes for $4.50. So I have to take that times 2, and I get 1.5 pounds for $4.50. Okay. Now to find out the unit rate, I need to find out how much in dollars per pound. So I have to find out how much 1 pound costs. So 1 pound over X. So then we are going to, essentially we'll be dividing. We have 1.5 X equals 450. Divide by 1.5. Divide by 1.5. Would have been better if I'd written this the other way, I guess, whenever we did that. But 450 divided by 150 is 3. So it is, I'm going to write the answer up here, $3 per pound. Because when you do 4.5 divided by 1.5, it's 3. So that's how much for 1 pound. Okay. Next, number 7, Sam is delivering 2 refrigerators that each weigh 150 kilograms. There's an elevator with a weight limit of 1,000 pounds. Can he take both refrigerators on the elevator in one trip? Okay, so first, 1 kilogram equals 2.2 pounds, about. That's what this means where it says about. It's not exact, but it's close. That's an L. Okay. So they weigh 105 kilograms, so that's going to go on top. And then my X, what I'm trying to find is how many pounds. That's going to go on bottom. Okay. So I'm going to cross multiply, and I have X equals 2.2 times 105. Oops, not 105. 2.2 times 105. There we go. Is 231 pounds. Now this is for one refrigerator because it says they each weigh that. So 231 pounds each. I need to take that times 2 to find out how much they both weigh. And that is going to be 462 pounds. And unless he weighs over 500 pounds, I think he's okay to take the 2 refrigerators on the elevator, because it can take 1,000 pounds of weight. This is only 462. So can he take both? Yes. And you could say both refrigerators only weigh 462 pounds. Okay. Now number 8. Light on here, so that helps a little bit. It got dark all of a sudden. For every 140 feet that Kelly rides on her bicycle, the wheels turn 20 times. About how many times do the wheels turn in 5 miles? I don't know who's making up these problems or why they want to know how many times her wheel turns. Okay, but we will figure it out. So for every 140 feet, it goes 20 times. We want to find out how many times it turns in 5 miles. And we have our unit rate here. So first we're going to start with 1 mile over 5,280 feet. That's our unit rate. Now we are going to convert 140 feet into miles. So I'm going to put my X on top. The feet has to match the feet, so 140 feet. Cross multiply now, and I get 5,280 equals 140. oops, this is x, sorry about that, 5,280x equals 140. So now I'm going to divide by 5,280 on both sides. And I get x equals, let's check it here real quick, 140 divided by 5280. I get 0.02651515 repeating. So I'm going to go ahead and round that to 0.03, which I think is probably fine to go 2 decimal places out. Now, that is 100, this is 0.03 miles for 20 turns. Okay? Because it said when she goes 140 feet, it's 20 times. So I have that part. Now I need to find out how many times is it going to turn for 5 miles. Okay? So I'm going to bring that down. I'm going to use this conversion that I have, 0.03 miles and 20 turns. And I'm going to find out how much it would be for 5 miles. 5 miles is how many turns? Okay? So I cross multiply. I have 0.03x equals 20 times 5 would be 100. And then I'm going to divide this. So 100 divided by 0.03 is a really odd number, is 3,333.33, and the 33 just keeps repeating. That is how many turns she's going to have in 5 miles. So a lot of these problems are requiring 2 steps. First you find one ratio, and then you flip it around and find the next part. So this one again was a 2-parter, just like several of the others that we've had. Kind of a tough lesson. The next one that we have tomorrow will be percents, so hopefully that'll be a little bit easier for you guys. And I hope you have a great day. If you have any questions, be sure to email me. I will get back with you hopefully within a couple of hours of you asking, if you're asking during the day. And if you ask in the night, I would hopefully get back to you the next morning. So be sure to ask questions. Be sure to check online for anything that you could do for science if you don't have your science textbook. And I will talk to you later.